By the mid-14th century, robust international trade networks had successfully linked the Mediterranean to Central Asia. But in 1347, when Genoese trading ships docked in Europe, they brought back a completely unexpected and deadly cargo. Within a few short years, the ensuing pandemic killed roughly 25 to 50 million people. That was up to half the entire population of Europe at the time. Physicians of the era were helpless to stop it. They largely relied on the miasma theory, the idea that the disease was caused by bad air, or they turned to prayer, neither of which slowed the spread. Humanity faced an apocalyptic, invisible enemy that moved much faster than their understanding of biology. The true culprit was microscopic. Looking at this electron micrograph, we can see the rod-shaped bacteria known as Yersinia pestis. This bacteria primarily lived in rodents and spread through their fleas. The bacteria would multiply inside a flea until it formed a dense biofilm, entirely blocking its gut. Starving, the flea would bite a human host and regurgitate the bacteria directly into the wound. After an incubation period of 1 to 7 days, infected humans developed the signature symptom of the bubonic plague: painful, severely inflamed lymph nodes called buboes. The outbreak grew even deadlier when the bacteria reached a victim's lungs. This created the pneumonic variant, which could spread directly from person to person through respiratory droplets in the air. Without immediate modern treatment, pneumonic plague has a mortality rate approaching 100%, often killing the host within 24 to 72 hours. Combining a highly effective insect delivery system with rapid airborne transmission, the plague functioned as the ultimate biological weapon against a defenseless population. The resulting death toll was staggering. In some regions, up to 60% of the population was wiped out, forcing authorities to dig massive, pre-planned trenches just to process the dead. As entire cities emptied out and the social structure fractured, desperate citizens sought extreme explanations. Groups known as flagellants marched through the streets, whipping themselves, believing the disaster was a divine punishment. But as the crisis passed, a paradoxical economic shift occurred. This animated chart shows how the massive population drop created a severe labor shortage, causing a sharp, sustained rise in real wages. With fewer people to feed, food and land prices plummeted, allowing laborers to demand better pay and specific working conditions. The sheer scale of the mortality inadvertently broke the rigid obligations of the feudal system, creating the economic groundwork for a mobile, independent workforce. This dynamic also played out on a biological level. Here is a recent anthropological study investigating the differences in survivorship and mortality risks before and after the epidemic. The data points to a concept called selective mortality. The Black Death disproportionately killed elderly adults and people who already had significant physiological stressors. The people who survived were generally healthier to begin with. Benefiting from newly available wealth and better diets, these survivors passed down their heightened immune responses to the next generation. As a result, archaeologists see a measurable increase in the general life expectancy of the post-plague European population. The mass trauma of the Black Death forced a brutal evolutionary bottleneck, ultimately forging a human population that was more resilient to disease. Given the medieval setting of the Black Death, it's easy to assume the pathogen is completely extinct today, but it isn't. This map shows the modern global distribution of Yersinia pestis. The bacteria remains enzootic in wild rodent populations, with heavily active hotspots in Peru, the Democratic Republic of the Congo, and Madagascar, which reported a severe outbreak of lethal pneumonic plague in 2021. In highly dense modern environments, an airborne pathogen with an incredibly short incubation period still possesses the ability to spread very rapidly. The biological mechanics of the disease remain exactly the same. The very pathogen that devastated medieval Eurasia is still waiting in the shadows right now. What has changed is our ability to fight back. Instead of relying on miasma theory, global health workers now use rapid diagnostic laboratory testing to immediately identify the bacteria. Once identified, the primary treatment protocol relies on something medieval doctors couldn't even imagine. Looking at this World Health Organization technical document, we see the recommendation for empiric antibiotic therapy using a single agent to cure bubonic plague. If the infection has progressed to the deadlier pneumonic or septicemic stages, the protocol escalates to a combination therapy using 2 distinct classes of antibiotics. When administered early, these antibiotics rapidly kill the bacteria. A disease that once promised almost certain death now has a high recovery rate. Our survival today relies on a combination of the biological resilience forged by our ancestors and the modern medical science that finally disarmed the deadliest pathogen in human history.